So to continue with our topic on fractions and particularly looking at adding and subtracting fractions, and we're going to be looking at how we do that with mixed numbers. In preparation for that, we're revisiting these skills that you've been asked to complete. So this is just a reminder about how you get equivalent fractions. That's one of the things you've met. And in order to fill in this first step, you've written 3/5 is equal to how many 20ths. So you're looking at what have I done to the 5 to change it into 20, and you have multiplied by 4. You need to do exactly the same on the top that you do on the bottom, which would mean that hopefully you've written 3/5 is the same fraction as 12/20. These are our equivalent fractions. So on this one here, clearly we're kind of working either backwards, or you have to think about what have you done to the 7 to change into 28, and that would be about timesing by 4. So what number do we times by 4 to get to the 36? Or you can think about it as going back the way. 28 divided by 4 gives you 7. 36 divided by 4 would tell you that what you're looking for in there should have been 9. So that's two ways of getting your equivalent fractions. You've also met how to simplify fractions, and when you are simplifying fractions, you're looking for what can I divide into the top and into the bottom. Now the most efficient way to do this is to try and pick the highest common factor with them, which here would be about dividing by 8, top and bottom, and that would give you an answer of 1/3. If you didn't spot the highest common factor, you might say, oh, 8 and 24, I can divide both of those numbers by 2, so that would initially give you 4/12, right? 8 divided by 2 is 4, 24 divided by 2 is 12. However, you can then still divide, you might divide by 2 again, or you might say, oh, actually I can now divide by 4. And if you divide by 4, you will get to the same answer of 1/3. And it's the 1/3 that you need to get to, because that's the simplest form. There's nothing else that we can divide into 1 and into 3 that will make it go to any smaller numbers. So that's it simplified. For 15 and 18, the biggest number that divides into both of those numbers is 3. So dividing both of those numbers by 3 will give you 5/6, and those are equivalent fractions is what you'd be looking for. So if you did a calculation and your answer came to 15/18, the expectation is that you would know to simplify it to 5/6. You should always be trying to have your answer in as simple a form as possible. Now, one of the other techniques that we use for working with adding and subtracting fractions is we need to think about something called the lowest common multiple, and that's basically the smallest number that is in both the times tables of the numbers that you're comparing. So here, right, if you were looking for the lowest common multiple of 5 and 10, so what's the first number that's in the 5 times table but it's also in the 10 times table? If it helps you, you can list your times tables like this. I would always start with a bigger number until you find the one that is in both times tables. Now clearly sometimes there's more than one number that's common, but it's the smallest one that you're trying to pick out. So here, right, that would be 10, would be the lowest common multiple between 5 and 10. For 4 and 6, you can see we've got the 6 times table, the 4 times table. There's a couple of numbers that are in common there, but the one that is the lowest, right, would in fact be the 12. They do both have the year 24 is common to both of those as well. However, it is the smallest number, which would be the 12 that we would be looking for. So know how to do that, know what we mean by lowest common multiple, because that helps us when we get on to adding and subtracting fractions. And as we know, if the bottom numbers are not the same, we cannot add the fractions. We need, or subtract them. We need the bottom numbers to be the same. Here we're dealing with eighths and halves, so we need to change the fractions. So lowest common multiple of 2 and 8, what's the first number that's in the 2 times table that's also in the 8 times table? And of course that is 8. That tells you that your bottom number of your fractions, both fractions, needs to be 8 in order to carry out this subtraction. Now the first fraction hasn't changed, so nothing happens with that. However, this one here, because you've changed the 2 from the bottom number into 8 by multiplying by 4, you also need to change the top number in the same rate, so multiplying by 4 as well. So a half is the same fraction, or the equivalent fraction, to 4 over 8. Now that the bottom numbers are in fact the same, it's basically a case of you are subtracting those top numbers. So you're just going to be doing 7 take away 4 to get your answer of 3/8. Make sure you don't just write 7 take away 4 here. You can miss that line out, it's not essential. You can go from this line down to the 3/8. So that's what happens when you've had to change one of the fractions. Sometimes, like in this next example, we're actually having to change both. So first number, we've got 6 and 9 on the bottom. We need to make them the same. So go through your 9 times table till you come to the first number that is in both times tables, the 9 and the 6 times table, and of course that is 18. So that tells you what the bottom number of each fraction needs to be. And of course, if you change the bottom number of your fraction, you also need to change the top number. So here, to change from 6 into 18, you have multiplied by 3. That means that we're going to have to times the 5 by 3 as well. So we will have 15 on the top there. To change the 9 into 18, you've multiplied by 2, so you also need to multiply the 4 by 2. So you will end up with 8 on the top of that fraction. So now that the bottom numbers are the same, we're now ready to just add the top numbers. So 15 add 8 makes 23 over 18. So we've got 23/18, that's an improper fraction, or top heavy fraction. So we're going to change that into and make our answer 18 into 23 goes in one whole time, so we know we can make one complete whole piece, and there would be 5 bits left over. So 1 and 5/18 would be your final answer. It is okay to leave your answer as 23/18, but it's good practice to work and interchange between mixed numbers and the improper fractions, which is what you're asked to do here. So question 5, change 31 into a mixed number. So 31 over 7. So we're going to do 7 into 31. So we do 7 goes into 31 4 times. 7 4s are 28. So you're then left with 3 as your leftover number. Now what that tells you is the 4 is going to be the whole number part, and the 3 is the remainder of the 7s that you've not been able to create into a whole number part. So if you're having to deal with a top heavy fraction and you're trying to get it into a mixed number, you're looking to do the bottom number divided into the top number. The whole number part will be this bit here, and whatever the remainder is how much of your fraction you're left over with. So last bit, change to an improper fraction. You've got 2 3/5. Each whole number 1 whole is the same thing as having like 5 fifths. So you can see there I've got 2 whole pieces, each with your 5 fifths, and then I've got 3 separate fifths. Now altogether, how many fifths can you see in front of you there? And you can see that each whole piece is 5 fifths, so that's a total of 10, plus the 3 that's left over. So that what that tells us is that 2 3/5 is the same thing as 13 fifths. Now a quick way to get there, not drawing diagrams all the time, is to take the whole number, multiply the denominator, and add on the numerator. So 2 times 5, add on the 3, and that's how you get the 13, the number on the top. The bottom number will always be the same as what you had before. And this last bit, any whole number can always be written over 1. Right, so that's not just for 5, that is in fact any whole number, right, can be written as a top heavy fraction by writing it over 1.